All right, we're venturing into the last two chapters of this class. Once again, my goal is to finish these two chapters, get a review, and get our final before we go out to Christmas break. That is my goal, to get through these two. Okay, and we should be able to do that. We have 3.5 weeks here. We should be able to accomplish that and get our final in. When we come back from Christmas break, we will then have a stats project that we will do. But I think it's a lot easier to get a final before break, just because everything is a little bit fresher rather than 2 weeks out, and who knows what's going to look like this week, next week, or any other week after this. So that is my goal, to push ourselves through this. We collect data. We organize data. We collect data, we organize data, we get values down there, we make guesses. And then we test these guesses at the very end. We are at the point now where we're going to test our guesses that we're going to have in regards to certain information or certain types of problems that we are dealing with. So this is called hypothesis testing. We've dealt with confidence intervals, that we are very confident that a population mean or a standard deviation will be in between these two values. And today we'll start dealing with the hypothesis testing. I hope everybody had a good Thanksgiving break. Hopefully we can make another 3.5 weeks out of this. Hopefully you didn't spend too much time with family and friends. When you talk about confidence intervals, you estimate the population parameters. When you talk about hypothesis testing, it assesses evidence and data for a claim about a population parameter. We start making claims about a population parameter. Confidence intervals, we use data to be able to estimate. Hypothesis is now we're going to make a claim about a specific parameter. I used to think this was the most difficult part of statistics, because when I was in college and I had to take this class, it was like, oh my gosh. When I had to take it for a graduate class, the guy never explained about hypothesis testing. We had to try to run ourselves through it. It was like, oh my gosh. Now that I've been teaching it for a couple years, this is probably the easiest part with respect to statistics. Hypothesis testing. It is a decision-making process for evaluating a claim about a population. Once again, if you are a big-time corporation, big-time business, and you're making products and trying to sell products, you make a decision about a business or corporation which is going to be beneficial to that corporation. I think right now would be the perfect time to manufacture and sell pools to start being put in right now. Swimming pools in Ohio. That would be awesome. Let's start making a big push and a big sell to get swimming pools starting to be put into the ground at this point in Ohio. Not a very good decision. It'd be a good time to deal with snow removals in the state of Ohio? Yes, it would be. So you make decisions. You look at making a decision about the population. We have a statistical hypothesis. When we talk about a hypothesis, we talked about hypothesis in science classes. What was your definition of a hypothesis in science class? Do anybody remember? You had a hypothesis. What was that? What was the definition of a hypothesis? Yeah, Trevor.
An educated guess?
Yeah, an educated guess. An educated guess. You're just not throwing a dart and saying, I hope this is true. You make an educated guess. You do this every day or every time on Sunday or Saturday when you go on FanDuel or you're setting your fantasy football teams. You're making educated guesses about players. And those educated guesses come from statistics. Oh, this is what they say they're going to get today. This is what they're projected. That's an educated guess. Well, how do they get that? Well, they look at the teams that they're playing. How good are they on offense and defense? How many times or how many teams run for 100 yards against this team? Do they have pretty good run defense? Am I going to play Nick Chubb against the Pittsburgh Steelers? Probably not. Why? Pittsburgh's pretty good defensively. Their run defense is pretty good. I probably would not take any running back against the Pittsburgh Steelers. Why? Because their run defense is pretty darn good. Well, that's a statistical hypothesis. That's a conjecture about a population parameter. It may be true or may not be true. Hey, you could say, I ain't playing Nick Chubb against the Pittsburgh Steelers because the Pittsburgh Steelers they're pretty good defensively. Nick Chubb may go out there and score 3 touchdowns against them. You don't know. You don't know. It may or may not be true. Hypothesis, it's an educated guess. We all do them. We're making an educated guess about tomorrow already. As we pull out our snow day probability, snow day calculator. It's not true until it happens, folks. I don't know if I've ever told this classes. I used to teach up in Lorraine. 6 years taught up there, lived in Vermilion, right on Lake Erie. Right on Lake Erie. It's on the west side, it's not quite snow belt, but up through 10 o'clock, they're predicting this huge snowstorm. You're going to get a foot of snow. They're predicting this at 10 o'clock at night. Everybody's sitting there saying, all right, I'll go to bed. I know when I get up in the morning, we're having a snow day. We're all good. I get up at 5:30 in the morning, start getting ready to go to school. All I hear is pitter-patter of rain on the rooftop. It wasn't Rudolph. It was rain. And it rained really hard. We got 0 snow. So that prediction of snow days and how much snow, we're going to get a foot of snow, is all rain. Now about 5 miles out on Lake Erie, it was a blizzard. It never made it to the land. So it's not true until it exactly happens. Hypothesis is an accepted value of a population parameter. We have 2 types of hypotheses that we will have to state for each one of these. First one's called the null hypothesis. And by definition, a statistical hypothesis states there's no difference between a parameter and a specific value, or there is no difference between 2 different parameters. Once again, you've got to get the definition down. We'll go through the definition. We'll break it down a little bit more. It is not tough to deal with. hypothesis states there's no difference between a parameter and a specific value. And we'll be dealing with mainly the population mean and a specific value. There's no difference between two different parameters. Is there a difference between the mean ACT score of males and females at Dalton High School? That would be comparing two different means. Is there enough to say that there is no difference between the average score, the mean score of the ACT for males and females in Dalton High School? Oh, we'll test that claim. The null hypothesis, once again, is an accepted value to test. I drop my keys. Sir Fig of Isaac Newton says, what's the acceleration of those keys? What's the pull of gravity on those keys? What's Sir Fig of Isaac Newton say it is? It remembers acceleration of gravity. What is it? Oh, goodness sakes. Yeah, 9.81 meters per second squared. That's an accepted value. It is accepted worldwide in the scientific world. I run tests, a pound test. I say it's 9.79 meters per second squared. Sir Fig of Isaac Newton is wrong, and I am right. So I'm going to test my value. The accepted value would be 9.81. I'm going to run that test. The alternate hypothesis, which I will probably use HA a little bit more because I like HA for alternate, is a statistical statement, hypothesis states that there exists a difference between a parameter and a specific value, or there's differences between two parameters. That day I lived up in Vermilion, this is what it sounded like on our rooftop. Right here. And they're predicting a bunch of snow tonight. We'll see it when it happens. Once again, I use HA. It depends on your book. Some books will use HA as your alternate hypothesis. Some will use H1. I use HA most of the time, but I'm going to write H1 up there also, just so you know. When we're talking about the alternate hypothesis, you can also use this mentality. It's what we hope is true. My example, Sir Fig of Isaac Newton. The average speed or acceleration of an object that's falling is negative 9.81 meters per second squared. What I hope is true, it's less than that. It's less than the 9.81 meters per second squared, or not equal to it. When hypothesis testing, we gather evidence against the hypothesis. We take a look at the probability of observing an outcome. So once again, we're dealing with probability, which means we're going to be dealing with area. Which means if we're going to be dealing with area, we're going to be dealing with a z-score. So we look at probability. We're going to be taking a look at area, and we take a look at area, you're going to be looking at Z or T scores. So we're going to be looking at calculating a Z-score with some given information. And we've done that. It's not going to change from what we just did. As the probability is significantly small, it leads us to doubt the initial claim. The first part of doing hypothesis testing is to get down the null and the alternate hypothesis. That will be step one. You write the null, you write the alternate hypothesis. You will then calculate a test value, and you'll make a comparison to a critical value, and we will either accept or fail to accept or reject or fail to reject the null hypothesis. But today, all that we're going to work on is writing null and alternate hypothesis. And you're going to get a worksheet today, and that's all you're going to be asked to do. You're going to be, I want you just to write the null and alternate hypothesis. Nothing else. There's mathematical things you want to do along the side because you're going to actually do mathematical computations on this tomorrow. A researcher thinks that expectant mothers use vitamin pills, the birth weight of babies will increase. The average birth weight of the population is 8.6 pounds. Now, going back to what we talked about with the null and alternate hypothesis, it is easier to start with the alternate hypothesis. Because the alternate hypothesis on the front side is what we want to be true. If expectant mothers take the specific vitamin, the birth weight will increase. Well, what's important about the birth weight of children or babies, newborn? Well, the more birth weight that you have, the more healthier they feel that the baby will be. So we want to have healthy babies. So we want to make sure that they get the vitamin pills to make sure we increase the body weight of newborns. So what we hope the true is that we increase that. That's what we hope is true. The average birth weight is 8.6 pounds. We just want to say it's going to be more than 8.6 pounds. We don't know what it's going to be. It's just, we know it's going to be more than. So what we hope is true is that mu is going to be greater than 8.6 pounds. That's what we hope is true. This is what we hope. If we take these vitamins, the average birth weight is going to be more than 8.6 pounds. What's it going to be? I don't know. I just know it's going to be more than. That's what we're trying to achieve. The null hypothesis is the SpongeBob opposite to the alternate hypothesis. So what is opposite than more than or greater than 8.6? Test. Less than or equal to. So the null hypothesis will be less than or equal to 8.6 pounds. The null hypothesis is what we expect to be true, or what is accepted. Equality will always go with. Equality will always go with the null hypothesis. Equality will always be with the null hypothesis. An engineer hypothesizes that the mean number of defects can be decreased if manufacturing processes of CDs by using robots instead of humans for a certain task. The mean number of disks is 18 per 1,000. What this engineer hypothesizes that if we use robots and automation, the mean number of defects is going to decrease. So we start with the alternate hypothesis. What is the hope is going to be true? What would he hope is going to be true? Lucas, what do you think? What's he hope is true? Because hope goes with the alternate hypothesis. What's he wanted? What is he stating here? That the mean number of defects can be what? Decrease. So what should we put? What? Less than. So he's going to say mu is going to be less than the 18 per 1,000. That's what he hopes is true. Then we go to the null hypothesis. Emily, what would be the null hypothesis then? There you go. So the alternate hypothesis, once again, is what we hope is true. A psychologist feels that playing soft music during tests will change the results of the test. He is not sure if it will raise or lower them. He wants to just play soft music. He wants to play some Bach and Beethoven, some sleepy elevator music in the background as you take tests. Doesn't want to play some Metallica, some AC/DC. Let's play soft music. He's not sure what's going to happen with the test results. They could go up or they could go down, but he feels it's going to change. The mean score has been 73. Not sure if it's going to go up or down. What do you think our alternate hypothesis is going to be? It's going to change. Not sure if it's going to be up or down. What can we do with our alternate hypothesis? It would change. Not sure if it's up or down. He doesn't know if it's going to go up or go down. He just knows it's going to change. What does he hope it's going to do? It's going to change. What do we put in between there? Not equal to. Very good. Very good. Mu will not be equal to 73. It's going to change. Not sure if it's up or down, so it's not equal to. Which means, what's the SpongeBob opposite to that? Carly? Mu is equal to. These are the three types of scenarios that you'll run into. I don't have any numbers on that one. Let's go down to the next one. A chemist invents an additive to increase the life of a car battery. if the mean life of the car battery without additive is 36 months. A chemist invents an additive to a car battery. He wants to earn some money. Hey, if we put this stuff in the car battery, we're going to increase the life of the battery. That's a great selling point to sell these batteries. The problem you run into, manufacturers sometimes don't want to do that. Why? They want everything disposable now and everybody it to go bad, so they have to come buy another one. So what would be your ultimate hypothesis? Write it down. Check with somebody around you. And then what would be your null hypothesis? What does he hope is true? That's your ultimate hypothesis. And then your null is the SpongeBob opposite to that. Max, what do you have for the ultimate hypothesis? U is greater than 36 because what does he want? He wants it to be more. Then that means the null would be what? Okay, last one. Contractor wishes to lower heating bills by using special type of insulation in houses. If the average heating bill is $78, write your null and ultimate hypothesis. Check your answer with somebody around you. Okay, if we look at the ultimate hypothesis, the ultimate hypothesis, what does he hope to be true, Caroline? Which means the null hypothesis would be what? That is correct. That is correct. This is the first step in dealing with hypothesis testing. Need to get a null and ultimate hypothesis. Tomorrow we will get into calculations and how we test these hypotheses. But today, all I want you to do, and keep this all to the left or along the top of the problem. Don't write it in the middle of the problem because you're going to have to erase. Just write your null and ultimate hypothesis. You have other information that's there. You got an alpha value. We utilize that to be able to calculate hypothesis testing. But all I want you to do is I want you to be able to go through and calculate or write a null and ultimate hypothesis for each one of these. There's keywords in there. You'll just look at less than, more than, less than, differs. When you just have the word differs in there, that's your equal to, not equal to. Okay, and that's all you'll be doing for today. Tomorrow we'll come in and we'll deal with the calculations of these. Questions?